Okay, there we go. Let's try this one. So they're giving me a right triangle there. Like that. And they're giving me A, B, C, and they're saying A is 2, so that's over here, because that's where they put A. B is 3, they put B down here, so B is 3. And they want me to find C. So how can I find C in that little triangle? Yeah, remember the Pythagorean theorem? We've done this before, huh? This isn't even hardly new for you. This is a nice little break from all that other mess. So A squared plus B squared is C squared. Pythagorean. You can use Pythagorean theorem whenever you have a right triangle. Triangle with a right angle in it. So right triangle, right angle. So that's going to be 2 squared plus 3 squared is C squared. What's that? 4 plus 9. 13 is C squared. Good to there. Am I racing ahead? You guys getting tired? How you doing? About an hour and 15 minutes of hard math. Or an hour and 25 minutes. A long time.
And I thought time flies when you're having fun.
Doesn't it? No. All right. Maybe we're not having fun. I don't know. So root both sides. So root both sides, and the root cancels the square, and it's root 13. Good. That's what we always do when we have a square, right? We just root it. Rooting. Have you seen the theme of this last part of the course here? Well, not the whole thing, but this last couple weeks, and roots and squares are opposites. That's a big theme. How about I just say that? Roots and squares are opposites, right? Squares cancel roots, roots cancel squares. They just undo each other, don't they? So if you have one of them, you do the other. If you have a square, you bring in a root. If you got a root, you bring in a square. Everybody's seen that pattern? It's just like bringing in the antidote, the opposite, right? All right, so the answer is root 13. I think they're going to have two parts. Don't they also want the calculator? Yeah. Yeah, so first off, they want the root 13 answer. They call that the exact answer because it's not a decimal that's been rounded. And then they want you to hit the buttons on your calculator, and you get 3.60555. And they say round proximate to 3 places. So remember how to round it through. You just circle the third place, and you look 1 to the right. You circle the place they want you to stop at. Third place. Look 1 to the right. If 1 to the right is 5 or more, which it is 5, you round up, huh? 3.606? Remember the rounding stuff? So that would be an approximate answer because we rounded. It's not exact, huh? Whereas the root 13 is exact because it wasn't ever rounded. Is that making sense? I'll move on. So this will be an easy section. So we got a triangle here. They're telling me B is 3, C is 5, and they want me to find A. All right, there's the right A. All right, so try that one. So write the Pythagorean theorem. So A squared plus 3 squared is 5 squared. We good? And that's A squared plus 9 is 25. Finish solving for A. So just subtract the 9. And A squared is, what is that, 16? Oh, yeah. And then what do we do to finish?
Oh, that's nice.
Just root it. Root it. So A is 4. And it's a 3, 4, 5 triangle. That's a typical one they do a lot of. 3, 4, 5 triangle. So there we go. Easy? That okay? I'm moving too fast? Is that okay? Oh, were you thinking about the plus or minus? Is that what you mean? Or how'd you get another answer, actually?
No, I mean, is that the only answer they want? Like,
That it, oh, I see. Do they want like an exact? Yeah, they do. Yeah, I see what you're saying. Yeah, just the 4, because this time it didn't come out a root thing. The difference in the last one is we got a root 13, so then we also need to do our calculator. Whereas this one, it's just, it rooted clean.
Okay.
So, yeah, so it's just exact. Yeah, I see what you're saying, yeah. And that one. A guy wire. How long is a guy wire reaching from the top of a 6-foot pole to a point on the ground 4 feet from the pole? Can you draw a picture of what they're talking about? Yeah, exactly. Is that good? So like, here's a pole, and then they have the string coming down to the ground, like that, and they're saying this is the wire, so it's a wire, not a string, and 6-foot tall pole, and I didn't draw that very well, because it's only 4 feet on the ground, huh? So the pole's supposed to be taller, and the spot on the ground is not as far. So 6 feet tall pole, 4 feet on the ground, there's the wire, this is the pole here. Does that make sense what they're doing? A little right triangle like that? How do we know that pole goes straight up like that? Did they ever say that pole goes straight up? Couldn't it be the Leaning Tower of Pisa pole? You know, couldn't it be leaning? What's that?
It would still be 6 feet long.
Would it still be 6 feet long?
It's a pole.
Oh yeah.
6-foot pole.
Oh yeah, 6-foot pole. But if this was like at an angle like this wouldn't be a right angle then.
Oh, yeah.
And we need the right angle because the Pythagorean theorem, a squared plus b squared equals c squared, is not true unless you have a right angle. So I would have to know that pole was straight up, wouldn't I?
That's called a Better Business Bureau.
No, they took care of it. You know how they took care of it? They said the word. Well, I guess they sort of did. They did. I assume they said height, but they didn't really. They just said the top. Yeah, so we'd have to assume it's straight up and down. When they say height, think about what does height mean? If I was to take a tape measure to measure my height and go diagonally down to the ground, I would be ready for the NBA, right? Be like 8 feet tall. Height means what? What is the very meaning of height? Straight down. You got to run the tape measure straight to the ground, huh? So when they say height, that means straight to the ground, doesn't it? Now they technically didn't say height, so anyway, we'll assume it's straight up and down. All right, can you solve for the length of the wire there? It's the same thing, right? It's a squared, b squared, c squared. So a squared plus b squared. And when you do the Pythagorean, a and b, the order doesn't matter. You can switch them around. The only one that's important is c. So which one is c there?
The hypotenuse.
It's the wire, the hypotenuse, yeah. So that one's the C, isn't it? So the A and the B, either order doesn't matter. 6 squared plus 4 squared, 4 squared plus 6 squared. So 36 plus 16 is C squared. 46, 52. C squared's 52. And then they want you to root it. Now, root 52, I don't think they'll take root 52. They want us to simplify that.
Where is root 52?
Yeah, so we got to clean up root 52. So let me take it over here. Just use your calculator. 2 times 26, 2 times 13. Like that. So 2 2's inside leads 1 2 outside. So it's 2 root 13. Remember the whole 2 for 1 deal? I broke down to 52. So whenever you break something down and there's 2 of the same thing, 1 comes outside, huh? On that. Question?
How come you're not just fitting it in my calculator?
Well, they asked for the exact length. Remember that means if you're doing your yeah, give me the calculator. Somebody have the calculator?
Yeah.
111. Yeah, you see now those ones go forever, don't they?
It's 0, 2, 5, 5.
Oh, okay. Then there's other stuff 0, 2, whatever. Notice it goes forever. So how can I give the exact? When they say exact, they ain't joking. They mean exact. And you see, any decimal, since the decimal goes forever, there's no way I could give them the decimal answer and be exact. I'd have to stop somewhere. I'd have to round, and then it's not exact. So that's how you know they want this answer, not the decimal. Does that make sense?
It's the same thing.
Well, this decimal goes forever.
Right, but it's still equal to the fraction, right? Or
Right, but it goes forever. So you understand what I'm saying? Am I making any sense?
Repeating decimal.
So in other words, how would you type into that box the exact, meaning no error whatsoever, unless you could type in the decimals forever? Because the decimals go forever. Anytime you stop, you're not exact.
Math Excel doesn't give you that little line above the last one.
It's not like that. It's irrational,
Yeah.
which means it goes forever with no pattern. There is no bar that'll cover it.
Oh.
It's an irrational number, like pi. Anyway, we're getting into deeper waters than we mainly. Yeah, there is no way to do that. Does that make sense? Why they're saying when they say exact, they mean the root version. When they say exact, they mean the root, because the decimal goes forever with no pattern. So there's no way to type in the decimal exact. Make sense? Let's try this out. Okay. During the summer heat, a 6-mile bridge expands 6 feet in length. Assuming the bulge occurs straight up the middle, how high is the bulge? Okay. What are they talking about? They're saying, suppose you build a metal bridge, right? And you fasten it tight on the two ends here. So what would that do? They don't now, because they learned an engineering lesson. If they fasten the two ends tight, metal bridge, what happens to metals when they get hot? They expand. You aware of that? Metals expand a little bit when they get hot. So if the two ends were tight and it couldn't expand, what would it do? It would have to pop up in the middle, like that. Otherwise, where's the extra space going to go? It's got to go up if it can't go out the ends. Now, in reality, now they build expansion joints so that in the summer heat, the bridge can expand sideways, and the winter cool down back down. But if they built them solid with no expansion joints on the ends, the bridge would have to pop up in the summer heat because it gets a little longer. Now, you might think, really? I mean, is it that big a deal? I mean, we have streets in Fresno that go up that high. I mean, right? I mean, who cares? Is it a big deal? Well, let's run the numbers and let's figure out exactly how high the pop-up would be if they didn't put in the expansion joints. So here we go. I'm going to actually do it. So I'm going to have the bridge this way, and then I'm going to have the pop-up version. Now I'll make it look big, but just so I can have a nice triangle to work with. So, and it comes like that, right? So, all right, so during the summer heat, 6-mile bridge. Now, one important thing you need to know is 1 mile. Anybody know? How many feet in a mile?
5,280.
I'm impressed. 5,280 feet in a mile. So you have to memorize that for the exam. I'm just kidding. You don't have to memorize that for the exam. I'll give it to you. You don't have to put it on your card even. I'll give it to you if I ask you a question like this on the exam. 5,280 feet in a mile. Okay, so what does that mean? Well, if the bridge is 6 miles long, doesn't that mean this is 3 miles and this is 3 miles, each half? I'm just cutting the bridge in half at the middle. 3 miles and 3 miles. It's 6 miles in the winter. This is the winter version. Here, I'll make it blue for cold. It's the winter version down here. It's when it's cold. The bridge is just straight 6 miles. You with me? But in the summer heat, the bridge pops up. And this part is going to be 3 miles plus 3 feet, because each side gets 3 feet longer, 6 feet total. And this side will be 3 miles plus 3 feet. Each side gets 3 feet longer in the summer heat, total 6 feet in length. That's not much growth. Everybody good to there? See how I'm doing that? Does that make sense? The bridge gets a little longer in the summer and pops up.
3 feet over 3 miles.
Yeah, that's only a foot per mile. That's not, that's 5,000 feet in a mile. In the summer, it just grows by 1 foot. Well, 1 foot's about like that. Huh? Yeah, so that's probably what it does. I don't know. You could type into Google and find out.
Can you explain that again, please?
So yeah, so I'm trying to make the red part up here a total of 6 miles, 6 feet. Because remember, the 6-mile bridge expands 6 feet, gets 6 feet longer. So in the summer, the bridge goes from 6 miles to 6 miles plus 6 feet. It grows 6 feet. In the winter, the bridge is just 6 miles. So they built it in the winter, and it's 6 miles from point A to point B. The bridge is. It's 6 miles, 3 miles, that's a 3 there. 3 miles and 3 miles, 6 miles. But in the summer, the bridge pops up because it goes an extra 3 feet. 3 miles, 3 feet, 3 miles, 3 feet. If you add those together, that's 6 miles, 6 feet, which is how long the bridge is in the summer. Is that making sense? So now, what is our job? To find the height. How much is the pop-up? That's what they want to know. The bulge. What's the height? Well, it's a right triangle. It's actually 2 little right triangles. We'll just work with the one on the left or the one on the right. It doesn't matter. Just work with one of them. You don't need both of them. Does that make sense, how we have a couple little right triangles? So let's do the right triangle thing, which is a squared plus b squared equals c squared. So a squared plus b squared is c squared. So remember, it's only important to identify the c. The a and the b are switchable. Who's the c? This right here, right? That's the C?
Yeah.
So that's 3 miles plus 3 feet squared. The other side, the A, is 3 miles squared plus B squared.
So we're gonna do everything in.
No, I'm going to change feet in a minute.
Oh, okay.
We all good to there, though? So 3 miles squared plus h, oh, I should make that h squared, plus height squared, right? So the 3, the h, and the 3 mile 3 feet. A, B, and the C. Good so far? 3, h, and then the hypotenuse is 3 miles 3 feet. Now let's stick in use your calculator. 1 mile, 5,280 feet. So multiply by 3. 3 miles is, I don't know, 15, 6, 8, 40, I think. Is that right?
15,840.
Good. 3 miles, 15,840. So this will be 15, we'll change it all to feet now. 15,840 squared plus 8 squared. And this is 3 miles, add 3. So if you add 3, it's 15,843, isn't it? Let me do that a little neater. Add 3, it's 15,843 squared. So everybody good there? So the 3 miles is 15,840, and the 3 mile 3 feet is 15,843. Is that good?
Those are some huge numbers.
Yeah, they're whoppers, aren't they?
Yeah.
So we good to there so far? I'm going to need some room here because, yeah, they're whoppers. Okay, so using your calculator carefully. Can I borrow a calculator? Thank you, Julio. So 15,840. Oh, you got the whole thing here. Good. So you get the right side. 251 649, and then the other side 15,840 squared. Oh yeah, 250,905 600. All right, there we go. Okay, so we got to solve for h. We know how to do that. $250, 905, 600. Subtract that from both sides. H squared equals. Yeah, that's a little messy, huh? Minus 251, 000, 649. What is it? 95049.
Okay.
And then root it. Last step. So, where's the square root button? There it is. Square root of answer. What? It didn't give me a good. Square root of 95049. I'm getting 308.3. I don't know what they want. Type an exact answer. Well, take the square root of 95049. Okay, so diagonal of a square has length 12 root 2. Find the length of the side of the square. I would draw a picture of what they're talking about. Let me let you do that. So draw yourself a square and put in the diagonal as 12 root 2.
So that would be the hypotenuse.
We good there? And they're asking me what's the sides. I don't know. Let me just call them x. Because I don't know what they are. And they're all the same, right? Because it's a square. All 4 sides are x. Because that's what it means to be a square. Sides are the same. So that's why I'm not using x and y. I'm using x and x, same letter, because they are the same length. Whatever they are, it's a square. I don't need these other ones. I don't even need all this stuff. I really just need this right triangle right here, huh? You just need half the shape, really, is all you need. That's a right triangle. A squared plus b squared is c squared. Pythagorean theorem yet again. X squared plus x squared is 12 root 2 squared. Does that make sense?
So x to the fourth?
Because the diagonal in a square makes a right triangle, doesn't it? Can we solve that thing? What's x squared plus x squared?
X to the fourth.
2x squared. If we were multiplying them, it'd be x to the fourth.
2x.
But it's 1x squared and 1x squared is 2x squared, right? When you're adding them, you add like terms, add the invisible ones in the front. The other side, remember how to do that? Remember when you got something outside of a root and something inside? Remember what happens? One of them gets rained on and the other doesn't. Right? The 12 gets squared, the 2 does not. It's protected by the root.
So 144 times 2.
288. We good? Am I going too quick? Does everybody see that? Remember when you're squaring and there's somebody outside the root, the 12 gets squared, and you calculate it, 12 times 12, and the 2 just stays 2. Why? Because it was protected from the squaring by its root. The umbrella kept it dry, right? Not good?
Oh, okay. So the answer is 12.
We all good?
So do we divide by 2 after that?
Yep, so to solve for x, divide by 2. 144.
Square.
And last step, root it, x is 12. Sides of the square must be 12. 12 by 12 square has a 12 root 2 diagonal. Is that good? By the way, that's always true. If you have a square that's, you could do the, you could 10 by 10 square, the diagonal will be 10 root 2. You could do the math. We don't got time. We got plenty of other math to do. It'll always work out that way. It'll always work out. If you have whatever, 7 by 7, the diagonal is 7 root 2. It always is for a square. All right, let's keep moving. Okay, so we're saying she measures 8 feet on one corner, 4 in another. My picture doesn't look right, but whatever. She make sure she has a square. She measures 8 foot from one corner, 4 foot from the corner on the other edge. How long should the diagonal be? So call this X or D for diagonal or whatever you like. So there we go. So I'm just going to go dot, dot, dot. Same thing. Good. I move on. Pythagorean. Just use calculator, round to the nearest thousand. That's all they want. Line okay? That too quick? Did it just solve right? You want me to write the equation? So 4 squared plus 8 squared is x squared. 16 plus 64 is x squared. 80 is x squared. Root it, root it. Hit the buttons on your calculator. Whatever the square root of 80 is. Is it 8.8 something? Probably 8.8, 8.9. I don't know. All right, I'm going to move on.